So hello guys, in this video we are going to solve this functional equation. Now read the problem. Find all function from f from n to n means we have to solve this function equation in the set n, and these there are three conditions. First condition is state that f of 2 equals to second, f of mn equal f of m into f of n for all mn in natural number, and third condition state that f is an strictly increasing function. So I have write that f of n equals n is the solution, is the only solution. Now we are going to prove it. So we will start by finding some initial value like f of 1, f of 3, f of 4, like that. So we are going to find f of 1. We will use this second condition to find f of 1. So put m equals 2 and n equals 1. We will get f of 2 equal f of 2 times f of 1. This will cancel out. Since it is not 0, it will cancel out, and then f of 1 equals 1. Now we are going to find f of 3, but f of 3 can't be found using this condition, because you can see that now we can find f of 4. How? Just putting m equals 2 and n equals 2 also. This will become f of 4. F of 4 equals f of 2 square. F of 2 square is basically 4. So we have f of 1. We have an f of 1 equals 1 and f of 4 equals 4, and we have f of 2 equals 2. Can we find f of 3 now? Yeah, we can find f of 3 using the third condition. Like, we know that 3 is greater than 2 but less than 4. So f of 2 will be less than f of 3, and f of 3 will be less than f of 4. And we know all these value, it is 2, it is f of 3, and it is 4. We have fully find that. So f of 3 lie between 2 and 4. Since function is defined for 3, it must be some value. So but it is f of 3 is natural number, so it will forcefully become f of 3 equals 3. We will use this idea, what we have done, this idea to in general to prove this. How? We will use induction. Induction is one of the most powerful tool when we are dealing with natural numbers. So base case, we are going to prove f of n equals n. We are going to prove f of n equals n, but by induction. How? This is the base case, that is f of 1 equals 1, which is true always. And now we let assume that f of 1 equals 1, f of 2 equals 2, so until f of 2n equals 2n. We have assumed that this proposition is true for numbers from 1 to 2n. Now we are going to prove this is true. This is true also for 2n plus 1, then we are done. But how can we prove that? You can notice that when we are going to find f of 3, we use two f's, the number just left and number just right 2, 3. In this case of 2n plus 1, we have the number on the left 2n, but we don't have a number on its right, but we can find the number on its right, f of 2n plus 1. How? Using the second property. It can be written as f of 2 times f of n plus 1. Since n plus 1 is less than 2n, it is also true for n plus 1, so it is become 2 times n plus 1, 2 plus n plus 1, or we can just multiply that to give 2. And now we can prove that 2n plus 1 is less than f of 2n but greater than f of 2n plus 2. This is 2n, this is f of 2n plus 1 is less than 2n plus 2, so f of 2n plus 1 equal to n plus 1, and we have hence proved. We have proved this using induction. We have let's assume what we have done induction, that we called it f of 1 equals 1. We have shown the base case is true, and then assume that f of 1 till f of 2n is true, and we are going to find the next number, this is f of 2n plus 2. And what we have done this, you can see. And thanks for watching.